Then we discuss as we discussed about the IP security protocol and that is actually what are the different features of this protocol and where it's providing the security. And as far as different versions of IP are concerned, like for example IP version 6 or IP version 4. So this protocol is as we discussed that it's mandatory for the IP version 6, but it's optional for the IP version 4. So that depends on the configuration of the IP protocol, that either that is using the IP security protocol. So it's because it provides the security to the data which is sent it in through the network. So that's why it's important as far as the security is concerned. So it's made mandatory for the IP version 6, but previously in the IP version 4, it was it's optional for the IP version 4, so we can use that this protocol with the IP version 4 or not. So it depends that how much security we are providing to the data, how much security we are providing to the data which is sent in, through the network. And then we discuss about different parameters as far as this architecture is concerned, like different modes, tunnel mode and transport mode, where we discuss what's the difference between them. Like for example, if we want to send data from host to host, it requires some encryption. Then it uses a transport mode. Then tunnel mode, uh, which is uh, which is uh, which is required to send the data from host to gateway or gateway to host. So for that we use a tunnel mode, and then we also define that in this protocol we are actually defining different policies, uh, security policies for some data or some packet which is coming into the network and which is going out of the network, and they are in the list of files or in the databases. So they are different, you can say, structures are used for that. Like for example, security parameter index, security policy database, and security association database. So they are different, you can say, databases used to save the information about the different policies which are used to provide the security to the data. And then we discuss about other other uh, parameters, like we discuss in detail the transport mode and tunnel mode and headers and the packet structures used for that. So we also discuss that, and then different databases which are associated to security of policies of the data, security policy of the packet. We discuss them, and then we, like for example here, uh, the databases for security policies, where different security policies are defined, are saved for inbound packets or outbound packets. We discuss what are the inbound packets and what are the outbound packets. If a packet is in the network and it's sent it to other networks, so that is inbound packet. Or if a packet is coming into the network and that's out of the that is coming from outside, and so that is called the outbound packet. So different policies are defined for the inbound packets and different policies are defined for outbound packets. And then we further discuss about the packet architecture for the IP security protocol, like what is in the authentication header, what is in the encapsulation header, and what are their purpose, and what are other fields are used for these protocols. So we discussed these things in detail in the previous lecture. And so this is a format, this is a structure of the protocol that we discuss about that. And then we also discuss about network address translation, which is used to make the public address to the private address, and how that is working when we are sending the data to other network, how that is working when any data is coming into the network. So we also discuss uh, that in the previous lecture as well. And uh, and so these different architectures which are associated with the security, we discuss about them and how we can combine these different architectures to provide further security to the data, and how they are using the tunnel mode and transport mode to securely send the data to other systems. So these are the things we discussed in the previous lecture, and now in this class we discuss about the web security. For example, how we can obtain the web security. So for the web security, we are required, uh, like for example, here. So you know that as far as the web is concerned, it is very important. You can say uh, feature or application or web application from where we can access different contents with the different, you can say, having different formats, so they can be easily accessible globally by the users. So in order to protect the data that is on the web, so we can have further, you can say, data security features also. For example, we can provide the data security for the web using the integrity, confidentiality, and denial of service and authentication. So basically, the thing is that for every data, we need to require the security or secure functions in this format. For example, if we are discussing about the data, or we were discussing about the network, for example, so we can provide the security for such type of systems using security functions, like for example, to keep the data, to provide the integrity using some hash functions, and to block some service that actually that is not authorized, or if we identified that if there is an intruder and it is going to access particular data in the system, and then we need to block that service, or we need not to provide that service to that user, so that other legitimate users can access the service. So in this way, we can have denial of service, sort of, you can say, different attacks can be used by an attacker. So we need to protect the system from such type of attacks. And also the different authentications are used, because we have to give the access to the legitimate users which are required to access the system. So that's why we need to provide the authentication to the data. Now uh, we have uh, we can provide the security at the web, for the web at the transport layer. Like for example, we say that there are the different layers, and we are providing the security at the different layers. And like for the web, it's we can provide the security functions at the transport layer. So the layer which is said to be for providing security for the web is called a secure socket layer. So here we are providing the security to the web in the form of secured socket layer. So this is particularly is working at the transport layer, and it was developed by the Netscape, and it also forms an standard for the transport layer. The standard which is formed at the transport layer, we say that it's called the transport layer security standard. And then it's this protocol, or this layer is attached with the TCP protocol, and it is different, we can say, protocols are used at this layer. So we will discuss them, that what are the different protocols which are used at this layer. For example, uh, we have this architecture for secure socket layer, and which are having different protocols which are used, like for example secure socket layer handshake protocol, secure socket layer chain cipher speak protocol, secure socket layer alert protocol, secure socket layer record protocol. So these are the different protocols which are used in this secure socket layer architecture. And whenever we provide the security to the data, whenever we provide the security to the web application, for example, so we provide the security at this layer. And what are their functions, how they are used. For example, whenever we are talking about the security uh, for the web application, so there's a client uh, and there's a server which are involved to exchange different messages between each other. For example, client is a web browser, and the server is a web server. So whenever any data has been exchanged between the client and server, for example, the web browser will send an authentication information to the server, and server will send the web contents to the client to access them. So in this way, we have different protocols are used for that. For example, we can use a handshake protocol, which is particularly used to make a connection between client and server. And we can use some protocol like cryptographic parameters can use for encrypting the messages which are being exchanged between a client and server. And there's a possibility that we can make multiple connections at a time or single connection at a time. So there are various connections are used. So it depends on the web contents which we are accessing. So that many connections can be established or can be connected to the server, or client can connect to the server. So we have different types of connections as we are discussing between peer-to-peer system or between a client and server. So they are forming different connections before they exchange the data with each other. They actually form a different connections to each other. And so for that, they are using different protocols. Like for example, there's a protocol which is used for this purpose, which provides encryption to the data, and which provides integrity to the data. So when we say that it provides encryption to the data, so it's providing using a protocol, different algorithms, like for example DS algorithm, 3DS algorithm, or AES algorithm. So these are actually the algorithms which are providing the security uh, in the form of encryption. And whenever we send the data to other system, so it's very important to send the data in encrypted form. And the algorithms which are used here, like they are symmetric uh, encryption algorithms, means that is actually whenever we encrypt the data, we use some key to encrypt that, and we use some key to decrypt that. So when we are using same key at the sender and at the receiver, then it is said as symmetric encryption. And when we are using the different key for the encryption and decryption, like we are using different key for encryption and different key for decryption, that is called asymmetric encryption. So here in this algorithm, it is using semantic encryption. The examples of semantic encryption are DES algorithm, 3DS algorithm, or AES algorithm. So each algorithm has its own features, and they are providing security on the basis of their features. So whenever we connect the client to the server, so we are using these algorithms to encrypt the data, so that we can protect the data from a taker, uh, that he cannot read the data without a proper method, or if he without a proper method, for example, if he doesn't have the key, then he cannot be able to decrypt the data or encrypt the data. So then we have some other methods like which is used to provide integrity to the data. So integrity means here if any change has been done in the data that could be identified by the receiver. So here we can apply this with the functions like message authentication code, like hash function, hmake, for example. So actually, the purpose of this method is that, or this algorithm is that they produce some value that is called as a hash value from the data or from the message, for example. So when this value is same as that of the receipt, that means the data or the message is not being changed. So in this way, they can use this type of method to provide the integrity to the data. And then we have some other methods like as I told you that there are the different messages are being exchanged between sender and receiver. They can send the messages to each other. So actually there is a field used here uh, for different messages. When different messages are sent, uh, they uh, they are this field defined as uh, a zero, for example. When any of the messages in the pending state, then this field is defined as one. So this is actually a digit that defines either the messages are in pending or all the messages have been sent to other user. So we will we discuss them this field as well, that whenever different messages are sent, how it becomes zero, and when different when any message is in the pending state, so it's one state. So it says a one state. So in this way, we say that different messages are sent, and this field define the state of the different messages. Either they are in pending state or they has been sent it to other system, for example. So then we have some other protocol that is called SSL alert protocol, which is providing some notification to the user if any of the error occurs in the data or in the network, for example. So there are the different types of notifications or alerts which are sent it by the user to the system. Like it can be a severe, you can say notifications or alerts, or it could be fatal alerts. Means it can, if they are not fixed immediately, they may harm to the system. So that's why we say they are called as a fatal errors or severe errors. And then we have different other alerts which are used to notify to the system, like some unexpected message or paid record make, decompression failure, handshake failure, illegal parameters. And when we are using different certificates to authenticate users to each other, like for example, when we authenticate a client to the server, server to the client, actually we will send different certificates to verify the users. So they are used for authentication. So we will discuss them, what is their purpose, how they are used whenever a client want to send or want to connect to the server. So before that, he will be authenticated by the server by verifying the certificate which has been sent by the server. And then we have if any certificate